Okay, so we have this parallelogram. They have special words for our parallelogram. In this parallelogram, B is the length of the base. Do you guys see my base? They've labeled it B. Then they call the S is the slant height. Because the S is, you see it's slanted?
Yeah.
So S for slant. Okay? So there are 3 different ways to find the perimeter of a parallelogram. Our first way be to add all the sides, just exactly like we said. How many sides does it have?
4.
So how many numbers should I be adding up?
4.
4. Okay? Or we could add the length of the base and the length of the slant height and multiply it by 2. Why does this work? Why does it work?
Because B plus B equals something, plus S equals something, and you have to multiply them together so that you can get the real answer like the A.
Okay, like look, how many S's do I have in my shape? 2. So I have 2S. How many B's do I have? 2 B's. So I could make, they've taken it out. They've done I've distributed the 2 to these, like in the distributive property, right? But if I pull it out, it would be 2 times S plus B would give us the perimeter. Right? Remember distributive property? Okay. So that's another option. Or you can multiply the length. So you can just do this. Either way. So this one here is similar, is what they're saying here. You can choose whatever way you want to do it. For me personally, I think adding up all the sides is just the easiest way to go. That's up to you.
Would you do it where, I mean, like, can you just, like, add up the sides? I mean, can you do it with a, like, if you were able to use a measure with,
A ruler?
yeah, will we just measure the, like,
Just the outside.
but, see, the part that I don't get is because, like, all the words and, like, the second one says multiply the length instead of
So it's just saying you're going to multiply the base times 2, because we've got 2 bases, and then you're going to multiply the slant times 2. That's all that one is saying. That's the same as this. 2 slants plus 2 bases. That's what that one is saying.
How come the top of it's called a base? I thought that'd be called a top.
Because the base, the bottom here, is congruent with the top. So that's why they're keeping it the same. Because the base of our shape and the top of the shape are congruent. So they're just going to say that it's both bases. Okay? Questions about how to add up the parallelogram? Alright. Yep. Okay, why do the equations for rectangles also work for parallelograms? Why does it work? Talk to your partner. Why do parallelograms and rectangles, the equations for both work? Okay, 5, 4, 3, 2, 1. Back up front. Why are the equations for rectangles, will they work for parallelograms? Opposite sides of a parallelogram are congruent, just like on my a parallelogram. Doesn't look too good there. So on a parallelogram, the sides would be almost the same as these sides, right? And the base would be the top and the bottom of my rectangle, right? So all my parallelogram is my rectangle, but they've taken the top of it and shoved it over, right? Here's the top. It's a slanted rectangle, yeah. It looks like a slanted rectangle, so that's why it'll work for both, okay? Okay, it says, will equation A work for all quadrilaterals? Will this work for all quadrilaterals? Add all the sides. Will it work for all quadrilaterals? Yes, because define perimeter, all you're doing is adding all the sides. So that one would be a yes. Will equation B and C work for all quadrilaterals that are not parallelograms? Could they? Could it work for a rectangle? Could you do 2 base plus 2 sides for this? Would it work the same?
Yes.
So this one would work. What about the second one? Yeah. So does it work for all quadrilaterals?
Yes.
What if I drew a quadrilateral that looked like... Would it work for that one?
No. It's not even a quadrilateral.
It's a quadrilateral. It's got 4 sides. Would it work for that?
No. No, it wouldn't. Yes, they're not all equal.
Are they all equal?
No, none of them.
Do they have congruent
No.
sides?
No.
No. So will it work for quadrilaterals that are not parallelograms?
No.
No, because this quadrilateral, right?
Yeah.
The quadrilateral, it'll work if the quadrilateral has congruent sides, right?
I know another one that it won't do it with. It's a crazy cake. Looks like bamboo.
So they have to have congruent sides for my equations to work. Could we change this to work for a rhombus?
Yeah.
If I had a rhombus, could I have an equation to work for a rhombus? Why? It looks like a parallelogram, so we could call one of these the base and one of these the slant. And would it be the same? Would that work? So for a rhombus, would it work? Would it? I think